How on earth do you take something hazardous, a waste product basically, and not just neutralize it, but actually turn it into a valuable resource? That's exactly what we're going to unpack today, looking at the technology that makes this amazing transformation possible. So here's our game plan. We'll start with the core problem, why this unit is so necessary. Then we'll walk through the thermal and catalytic stages, which is where all the magic really happens. We'll see how the tail gas treatment unit pushes for perfection, and then we'll switch gears from theory to the real-world, practical side of a safe startup. All right, first things first, let's talk about the why. Why does this unit even exist? It all comes down to solving a very specific and very hazardous problem that's a natural part of refining crude oil. The problem is this stuff called acid gas, and it is loaded with toxic hydrogen sulfide, or H2S. You can't just release it, and if you just burn it, you get sulfur dioxide, SO2, which is a major pollutant. So the SRU is the really clever solution. It intercepts that dangerous H2S and chemically transforms it into pure, bright yellow elemental sulfur. It literally turns an environmental liability into a valuable product for fertilizers, rubber, and all kinds of other industries. Okay, let's step inside the process, starting with the thermal stage. This is where the whole conversion kicks off, and it all happens inside a massive piece of equipment called the reaction furnace. Now, take a look at this schematic. What's so interesting is what it tells us about the conditions inside. This is no ordinary furnace. It's a highly specialized thermal reactor. That lining you see is called refractory. It's layers of high-tech fire bricks designed to handle scorching temperatures that would just melt ordinary steel. So, what's the secret inside this incredibly hot furnace? Well, it's all about precise control. At over 1,000 degrees Celsius, you add just enough air to burn exactly 1/3 of the incoming H2S. This isn't random. This controlled burn turns that portion of H2S into SO2, creating the perfect 2-to-1 ratio of H2S to SO2 that the rest of the process absolutely needs to work. Okay, so we've created that perfect gas mixture. What happens next? Well, now we head over to the catalytic stage, which is where the real workhorse of sulfur conversion takes over. This entire stage is built around the famous Claus process. The hot gas mixture we just made now flows over these beds of solid catalyst pellets. And it's right there, on the surface of these catalysts, that the rest of the H2S and that brand new SO2 finally meet, react, and combine to form pure elemental sulfur. And, the process is really smart about this. It's not a one-shot deal. To get the maximum recovery possible, it all happens in multiple stages, and each one is a perfect little loop. Reheat the gas to the sweet spot for the catalyst, run it through the reactor to make more sulfur, and then cool it all down in a condenser to let that liquid sulfur literally rain out so it can be collected. So after that final Claus stage, we have recovered a huge amount of sulfur. We're close. But we're not aiming for close. We are aiming for 99.9%. And to get there, to hit that target, we need one last high-tech purification step, the tail gas treatment unit.
Think of the TGT as the ultimate recycling system. It takes the leftover gas from the Claus section, the tail gas, and through its own process, it converts nearly every last stray sulfur molecule back into H2S. Then it sends that captured H2S all the way back to the front of the plant to start the whole journey over again.
And that right there, that's how you hit the big number. It's this tireless recycling loop that transforms the plant's efficiency from just good to truly exceptional. The TGT is the key piece of tech that makes that 99.9% target a reality, making sure the absolute minimum gets out into the atmosphere. Okay, so understanding the process is one thing, but safely bringing this entire massive unit to life from a complete shutdown, well, that's a whole different ballgame. We're now shifting from the chemical theory to the disciplined, real-world procedure of a unit startup. The very first decision an operator makes is this. Is it a cold startup or a hot one? A cold start is for a totally clean unit. A hot start is when the unit was just shut down and there's still sulfur inside. And this choice is absolutely critical because it dictates what kind of gas you use for purging. If there's no sulfur, you can use air. But if sulfur is present, you must use an inert gas, like nitrogen, to avoid creating a potentially flammable atmosphere. And the sequence is always the same, always logical. You don't just flip a switch. First, the incinerator, your final safety net, is fired up and brought to temperature. Then, a flow of hot gas gently and evenly warms up the entire massive Claus section. Next, the amine system starts circulating, and only when every single one of those steps is complete and all systems are go, do you begin to slowly and very carefully introduce the acid gas. Now, throughout this whole process, operators are tracking hundreds of variables. But before a single molecule of hazardous gas can enter this system, there is one number, one temperature, that is the absolute, non-negotiable gatekeeper. And that number is 600 degrees Celsius. The tail gas cannot be sent to the incinerator unless its combustion chamber is hotter than 600 degrees. This is a critical safeguard. It guarantees that if any tiny trace of H2S slips through during the startup, it will be instantly and completely destroyed by heat. No exceptions. And this quote, pulled directly from an operating manual, tells you everything you need to know about the culture here. Every step, every temperature, every single waiting period has been precisely calculated for safety. In an operation like this, there is zero room for shortcuts or making things up as you go. The procedure is everything.
And that wraps up our tour of the sulfur recovery unit, a brilliant process that turns a problem into a product, all while protecting our environment. It really makes you wonder, doesn't it? As regulations get even tighter, what kind of innovation will it take to push this essential technology beyond 99.9%? Thanks for joining me.